As the sun rises, the vast machinery of modern agriculture begins its relentless, automated harvest.
A closer look shows harvesters moving in synchronized patterns, like factory production lines.
The camera shifts to a mechanical close-up of harvesting headers cutting through crops with precision. Internal mechanisms transport harvested material through conveyors inside the machine. A shot reveals the massive storage tank, filling rapidly with harvested crop material. The camera highlights an unloading arm transferring crops into a transport vehicle beside the harvester. A tracking shot follows multiple transport carts traveling toward storage facilities in a coordinated flow.
The scene shifts to storage infrastructure, large silos and conveyors waiting to receive harvested crops.
A close-up shows conveyor belts receiving crop material and moving it upward into storage. Wide visuals compare agriculture to an industrial-scale operation, with machines working like mobile factories.
This montage showcases the diverse environments of the harvest, from sprawling orchards to open fields and efficient processing zones.
This intense, industrial-scale operation sees massive machines moving non-stop, a continuous mechanical ballet during peak harvest season.
A clean, wide establishing shot introduces the orchard as the first stop in the harvest cycle.
Close-up mechanical detail shows a fruit collection mechanism gently guiding apples into bins.
The camera transitions to root crop harvesting by showing a large digger entering a field.
A detailed close-up shows rotating digging components lifting soil and crops into the machine.
A sorting conveyor separates roots from debris using vibration and airflow. The scene shifts to storage vegetables, large bins receiving harvested produce by conveyor.
This massive warehouse facility features advanced automation, with stacked crates moving efficiently along the automated intake lines.
Land preparation begins with heavy tillage equipment, breaking soil in wide, sweeping passes. Close-up detail shows rotating discs and blades cutting and mixing the soil precisely.
Welcome to the future of agriculture. Our high-speed harvest system moves successive crops.
A peanut harvesting unit lifts plants and shakes soil loose in a controlled mechanical process. A sweet corn harvester cuts stalks and pulls ears through intake rollers in rapid cycles. A pistachio shaking system is shown vibrating tree trunks while catching falling nuts in collection frames.
The sunflower harvesting header pulls the seed heads directly into the cutting and separation unit.
The documentary theme locks in speed, scale, and precision, shown through synchronized machine motion across multiple farms. A final wide shot compares modern farms to production systems with continuous transport and storage flows.
A wide establishing shot sets Washington-style orchards as a massive mechanized harvesting zone.
Here we see the synchronized formation of our automated harvesting systems, moving seamlessly through the orchard like a high-tech assembly line.
Close-up reveals heavy-duty tree shaker equipment approaching a trunk alignment point.
As the hydraulic pistons pressurize, the padded gripping surfaces engage, locking the tree trunk firmly in place for transport within the factory. A macro view captures the vibration modules initiating controlled shaking through the clamp system.
Wide shot shows the tree canopy shaking while apples fall rapidly in a dense stream.
Slow motion close-up captures apples impacting the ground and rolling outward across soil and grass.
A machine-mounted camera angle shows shaker clamp release and repositioning for the next tree.
The windrower enters frame, designed to push fallen apples toward the middle of the row. close-up shows dual sweeping paddles pushing apples from both sides into a neat central line.
A top-down drone angle reveals an evenly formed windrow line stretching down the orchard lane.
The apple pickup harvester rolls in low to the ground, its intake system aligned to the windrow. Close-up shows soft, rotating rubber fingers gently scooping apples upward. A belt conveyor carries apples upward inside the pickup harvester in a continuous stream.
Air blowers activate above the belt, pushing away leaves and light debris.
A debris separation chute collects lightweight waste while apples continue forward on the belt.
Apples drop into a large bin with padded walls designed to minimize impact.
The footage captures the heart of the operation, where advanced automated machinery fills these large harvest bins rapidly and
A close-up shows apples stacking and rolling inside the bin, revealing small bruising marks on surfaces.
The bins are hauled away by industrial transport equipment toward processing storage areas. As the bins arrive at the sorting yard, they are fed directly into the automated conveyor intake systems.
Introducing the improved shaker system. As the machine positions itself, the catch frame rapidly unfolds beneath the tree canopy.
Close-up shows padded catch surfaces forming a funnel-like shape around the tree base. The clamp locks in place and the shaker vibrates, dropping apples onto the catch frame instead of soil. Apples roll down the catch frame toward an integrated conveyor intake opening.
The integrated conveyor lifts apples into a clean bin without ground contact, preserving quality.
the ground drop technique scatters the fruit, causing damage, while the padded catch frame system ensures a gentle landing and preserves quality.
An over-the-row harvester appears, straddling a tree row with sweeping brushes inside the canopy zone. The close-up shows brushes flexing gently as they dislodge apples into collection trays. Collection trays guide apples into a conveyor channel traveling toward bins.
A wider shot shows continuous movement. The machine advances while apples are harvested and transferred simultaneously.
This is the next era of agriculture, where robotic harvesting arms manage a controlled orchard system.
The footage captures the AI camera modules meticulously scanning each tree branch, utilizing structured light to detect the perfectly ripe apples.
A robotic arm reaches into the canopy, aligns, and gently removes a ripe apple using a precision gripper.
The picked apple transfers into a cushioned conveyor channel designed to prevent bruising.
The montage highlights the synchronized precision of these robotic harvesting arms, repeating the pick-and-place cycle continuously across thousands of branches.
The segment closes with a production-scale orchard logistics view. Machines, bins, and transport flow in constant motion. A wide establishing shot shows a large carrot field ready for harvest, with machinery staged at the edge.
The harvester enters the rows, its digging blades aligning precisely with carrot beds.
Close-up shows the digging system cutting into soil and lifting carrots upward in one continuous flow. A mechanical macro shot shows gripper belts holding carrot tops and pulling roots cleanly from the ground. Vibrating separators shake soil loose as carrots move upward along the machine's internal conveyors. A side view reveals the one-pass workflow, lifting, cleaning, and moving carrots through the system without stopping. A cutting mechanism trims carrot tops cleanly with rotating blades, leaving uniform roots for transport. Trimmed tops are conveyed into a separate chute, forming a continuous waste stream away from the main crop line.
A pre-sorting conveyor shakes and spreads carrots, separating smaller debris and clumps before loading.
Optical sensors and mechanical diverters guide carrots into uniform streams for bulk handling. A dramatic overhead view shows thousands of bright carrots flowing across conveyors like a factory production line. A bulk loading conveyor transfers carrots directly into a transport container in the field. Close-up shows controlled carrot flow and impact reduction inside the transport container using sloped padded surfaces. A wide shot shows the harvester and transport unit moving together. Continuous harvesting with no downtime.
The camera follows multiple transport containers leaving the field like a supply chain convoy.
The intake facility processes thousands of carrots every hour, moving them from the field containers into the industrial storage system.
This closing shot emphasizes the industrial scale volume, with carrots flowing endlessly through the mechanized systems.
A wide establishing shot shows a large onion field in late summer, set up for a harvest focused on storage quality. A windrower enters the field, lifting onions and forming long, continuous rows. Close-up shows lifting shares cutting beneath bulbs and loosening soil as onions rise onto a conveyor. A macro shot captures onions rolling gently off the conveyor into a uniform windrow on the surface. A high overhead view shows multiple windrows stretching across the field like organized production lanes. Time-lapse visuals show these onions curing on the ground under the sun and airflow, essential for long-term storage strength. Close-up detail shows outer onion layers drying and becoming papery, emphasizing shelf life preparation. The pickup harvester arrives and aligns its intake system directly over the windrow.
Rotating tines lift onions gently and feed them onto a conveyor without damaging the skins.
A conveyor transports onions upward while loose soil drops through vibrating grates beneath. Soft brushes rotate over onions, removing dust and loose skins while maintaining gentle contact.
Air blowers activate to remove papery skins and lightweight debris from the moving crop line.
A sorting deck separates market-grade onions from off-grade ones using mechanical diverters. Close-up shows market-grade onions dropping into a large bin or trailer running alongside the harvester.
Off-grade onions travel down a separate chute into a dedicated container for processing use.
A wide shot shows the entire system operating like a mobile processing plant. Pickup, cleaning, sorting, and loading.
A wide establishing shot introduces a vast open field with heavy soil preparation machinery staged like industrial equipment.
The deep plow machine begins moving forward, pulling a large multi-blade plow assembly into the ground. Close-up shows thick steel blades cutting into soil, with dirt rolling upward in heavy waves. A low-angle tracking shot reveals the depth of the cut as the blades drive far below the surface. A mechanical close-up shows hydraulic cylinders adjusting plow depth with precision under heavy load. A cross-section style visual shows a compacted hardpan layer breaking apart beneath the blades. Close-up shows soil chunks fracturing and loosening as the plow passes, leaving a rough, aerated structure behind. A wide shot shows the machine's long pass creating deep, uniform furrows across the field. A slow pan highlights the contrast between compacted, unworked soil and loosened, plowed soil behind the machine. A drainage-focused visual shows water flowing more easily through loosened soil channels after deep plowing. Across these vast expanses of cereal and oilseed farmland, synchronized deep plowing machines emphasize the sheer. A wide establishing shot introduces a shallow plow system moving across an open field at steady speed. A low-angle tracking shot shows shallow blades and discs working close to the surface, lifting topsoil uniformly. close-up shows residue from previous crops being sliced and mixed into the topsoil.
A macro-mechanical shot reveals rotating discs, cutting and churning soil with consistent depth control.
A side profile view shows topsoil loosening and forming a fine textured seedbed behind the machine. A cross-section style visual emphasizes a growing humus layer where residue blends into organic rich topsoil. A weed suppression visual shows shallow disturbance, uprooting small weeds and exposing them to sunlight.
A pest disruption visual shows residue being turned and broken, reducing shelter zones for pests.
A wide cinematic shot shows prepared seedbeds stretching across farmland, uniform and ready for planting. These advanced shallow plow systems are revolutionizing agriculture. They work across diverse environments, from dry corn.
A wide cinematic shot reveals a massive seed planter unfolding across a large field like metal wings.
A tracking shot follows the planter moving steadily forward, its long multi-row system covering huge ground. Close-up shows a large hopper filled with seed, agitated slightly to maintain smooth flow. A mechanical macro shot shows internal metering discs, controlling seed flow with precision. A clear view shows distribution tubes carrying seeds downward toward the soil in continuous measured pulses. A close-up reveals furrow openers cutting narrow grooves into soil, creating precise planting channels.
Seeds drop into the open furrow at consistent spacing, captured in slow-motion detail.
Closing wheels press soil gently over the seeds, sealing the furrow with uniform compression. A macro shot shows press wheels and firming strips, ensuring seed-to-soil contact for strong germination.
A wide shot reveals perfectly aligned planted rows stretching behind the planter in a precise grid-like pattern. These precision control modules and antenna units are the heart of our new GPS guidance system, ensuring unparalleled accuracy in the field.
Close-up shows sensor arrays monitoring seed flow and detecting blockages in real time. Row alignment correction is shown by auto-steering linkages, adjusting the planter position precisely. Variable seeding rates are visualized through metering units changing speed as the planter moves.
This clean visual comparison highlights the results of precision planting, showcasing perfectly uniform crop row spacing. The segment closes with a massive aerial shot of planting at scale, machines carving precise lines across the landscape.
A wide establishing shot introduces a large peanut field with harvesting equipment aligned like an industrial deployment. The digger shaker cuts under plants and lifts them, exposing pods and flipping vines for sun drying. Aerial view shows long inverted windrows of peanut plants curing under the sun like organized drying lanes.
A combine harvester lifts dried windrows and separates pods from vines using internal threshing drums and blowers.
The sweet corn harvesting machine moves rapidly through the dense rows, its synchronized header motion emphasizing the speed. Close-up shows gripping rollers pulling stalks inward, while cutting units slice and strip leaves in rapid cycles. Corn ears travel onto conveyors, moving upward at high speed toward bulk collection. Bulk unloading transfers corn into a transport trailer moving alongside the machine in continuous flow. A pistachio shaker clamps onto a tree trunk using padded hydraulic arms and begins controlled vibration. Umbrella-like catch frames collect falling pistachios instantly and funnel them into conveyors. Fans and blowers remove dust and leaves as pistachios move along a clean conveyor line into bins. Fans and blowers remove dust and leaves as pistachios move along a clean conveyor line into bins. The mature sunflower fields are ready, their heavy heads drooping with seed. As the combines move in, close-up shows heads entering cutting units and moving into threshing drums, where seeds separate instantly. Close-up shows heads entering cutting units and moving into threshing drums, where seeds separate instantly. A final montage-style wide shot shows multiple mechanized systems, harvesters, conveyors, and storage flows.
A final montage showcases the mechanized systems, harvesters, conveyors, and storage flows.